you said that the torque is equal to F times D. And its unit, that torque, is a Newton meter. Now, why I'm saying this one? Because there's actually one condition of equilibrium states that the total torque should be 0. Is that right? Yes. So if you have a case like this one, pay attention. You have, just like this one, this beam which is pivoted at the center from here. When I say at the center, I think it's clear. If we put simply two objects at different distance from the center, like this one, this is object 1, say it's 10 Newton, and this is, say, it's 15 Newton. If we know the distance, this one, simply, if I say this one is D1 is equal to 10 centimeter, can you find D2? Yes, we can find it simply. How we find this? We apply the formula that total torque should equal 0. That means, this means, when you say that total torque equals 0, that we have a positive torques and negative, and these torques, they are equal. In other words, we say we have clockwise and counterclockwise torques. So according to this, I'm going to write the following. See, we have a case. I'm going to write clockwise torque should equal counterclockwise torque. Is that clear for you, Shabab? This is clear. If that's clear, tell me. Now, here we have this pivot. So this force has clockwise, and this force has, please, you figure it out. واضحة لكم يا شباب هذا؟ Sorry. واضحة الله يبارك فيكم؟ So, what we do, we simply apply the formula. استخدم القانون. We say F1 D1 should equal F2. By the way, this is my advice to all of you. You don't have to write positive and negative. You just make the clockwise equal the counterclockwise. Yes, just only direction. Don't actually put yourself in it. Now, in this one, we have F1, suppose this is here. We say 15 times D equals 10 times 10, because this is 10, it's given. So we can find D. Is there a problem with that? It will be 100 over 15, and the answer will be in centimeter. This is at the beginning. This is an idea. So we have two things. Sometimes, the measurements will be given on the same beam, on the same ruler. I'm going to give you an example of this. Here, this is given that it is 10 centimeter, and you have just fine. In other problems, maybe in problem 2, you have the same thing, but you have this is 0. You have measurements 10, 20, 30. This is here given. 20, 30, 40, okay? You can say we have an object here and we have an object here. Okay, now if this object has a, say, 10 Newton, how much is this one? This is called W. From this, can we find the distance? Yeah. From the pivot? Of course, I'm so sorry. There is a pivot at the center. So we can find it easily because we know how much distance from here to here, Shabab. Say it.
20.
20. And from here to here? 30. You just write F1 D1 equal F2. And we assume that this is 10 times 30 equal W, that's weight, times 20. And this we simply find W equal 300 over 20, which is 15 Newton. This is an approach. Is that clear?
Yeah.
واضح يا شباب؟ طيب, let me give you one more point. Sometimes يا شباب, we have two objects, not only one object. So let's say this is 40, I'm going to put this one here. And this is, I will ask for, it is 5 Newton. What actually modification we try to do this? Of course, we assume that the beam is balanced, and يكون متوازن. لا هو مايل لليمين ولا مايل لليسار. In this case, I'm going to say F1 D1 is equal to F2 D2 plus. That's simple, yeah. So see what I'm going to do. I will write here, F1 D1 is equal to We have 3 forces now, not 2 forces. 3D, 3. So precisely, F1 is 10 times 30 equals, never mind, we can we find W times 20 plus 5 times, how much is it? 40. First of all, you just find, you solve this for W. How is it simple? It's 300 equal 20W plus 200. Is that right?
Yes.
Send this 200 to the other side. It will be negative. So 300 minus 200, how much is it? 100 is equal to 20W. So finally, W equal 5 in Newton. Is that clear?
Yes.
Because this is 100 over 20 is 5. This is the second idea. How is it? Okay? I'm going to give you one more idea. See, Ishmael. I will erase this. In the third idea that I care about it, sometimes, Ishmael, we have something called by the center of gravity. If you have a ruler, that ruler has center of gravity which is positioned at the center of it. Because we say that the ruler has a regular shape. It has a regular shape. So its center of gravity will be at the center. Now, if we simply actually displace the pivot, not at the center of gravity, and they will ask you to find how much actually the mass of the ruler. I'm gonna give you an example. See, Ishmael. Suppose we have this ruler, like this. This is the 0, and I'm gonna say this is 10, suppose, 20, 30. This is similarly 10, 20, 30. See, Ishmael. Let's say, for example, that I put here my pivot here. This is my pivot. And there's one object here which weighs that object, say 20 Newton. I'm giving random numbers, Ishmael. There is another object here which weighs, for example, say 10 Newton. Did you know what they asked for? Find mass of the ruler. How we find it this one, Ishmael?
Only the roller?
Just yeah. By the way, everything is given here. There is no here. You don't have unknowns. Everything is given. So how we find the mass of the ruler? You attend last week the class? Yes or no?
No.
We did this last week. The same question.
No,
We did this at 10.
we did that last week. So
All of you?
Yes.
Right. I'm sorry, I thought that you attend the same. Sometimes you all look like all of us, all of you similar to me. Okay, Shiba. Mass of the ruler, you should know that. The mass always, the center of gravity of the ruler is always positioned at the center, at the 0. What we say, Shabab, simply, this is, you should draw it by yourself. Oh, I've got this one. This one is not the mass, it's W of the ruler. From W, I'm gonna find the mass. Okay? See, this is your pivot. In the pivot, on the right of the pivot, you have one force. On the left, you have 2 forces, W and 10. Is that right? So I'm gonna write the following. See, Shabab, directly. F1 D1 plus F2 D2 equals, okay, 2 forces, and this is 1 force. This is my F1. It's 10. How much distance?
40.
Allah yas'idkum. This is distance. You don't care about the 0. You care about the pivot. This, so times 40 plus W times, say 10, because this is from here to here, equals F3 20 times, say from here to here, how much is it?
20.
Allah barak fikum. That's simple. Okay, I'm gonna solve this one. This is 400 plus 10W is equal to, let me just change this because this will be 400, 400, they will cancel together. Okay, I'm gonna make this, ya shabab, only, sorry, I will make it 20. Just one, I will change this one. So it will be 800, okay?
Yes.
Now this will be 400. Now we send this to the other side. It will be now this 400, is that right?
Yeah.
So I'm gonna write here the issue as follows. W equals, it will be, Shabab, here, if we send it, of course, 400 over 10, and it will be 40 newtons, suppose. By the way, I told you, Shabab, it's not balanced as a problem. It is negative, by the way, but I skipped the negative. Suppose it's not negative. Now, if the weight is 40 newton, how much the mass? So it is 4. It is 4 kilograms. This is simple. Okay, Shabab? So from here you can find the Shabab, the mass. You know that the mass is weight over G. That is 4 kilograms. This is a good question, by the way, Shabab. I'm saying in general, Shabab, the question will come on these that we expected. There's nothing else, because they will give you a situation and you have to solve according to that situation. Please, you should always put this in your mind. Your reference point is your pivot, not the center, not the zero. Where the pivot, you measure from the pivot. Just like this problem. We measure from where? From 10, not from 0. Is that clear? طيب يا شباب. I will leave this for you. Now we go to the next problem.